Setting up a PC Part 1 of 2. This is the first of a two-part mini-series on what goes into the interfaces and connectors in setting up, or kitting as it's called, putting together a PC. We're going to start with a review of common interfaces. An interface, you'll recall, simply refers to the connection point between two pieces of hardware. This could be an external device interfaced to the computer's motherboard, or it could be inside the case on the motherboard directly, interfaces between internal devices like hard drives, optical drives, RAM modules, CPU chips, and the motherboard circuitry itself. Then we'll pay particular attention to network connectors. Certainly, much of what we'll look at in this nugget is a review of concepts that we've examined earlier in the course. However, please don't be dissuaded. Number one, as you know, a principle of adult education that's quite paramount, at least in my experience, is that repetition is the seed of mastery. And number two, you're going to see these kinds of things and references to these interfaces and connectors on your Strata IT for Sales exam, and you'll certainly be seeing this stuff in your professional lives as IT sales or pre-sales representatives. Without any further ado, let's get to work. The first kind of connector or interface we'll look at are video interfaces. We've talked about video cards. Inside the computer, on the motherboard, video cards tend to use the PCI slot or the PCI extended PCIe bus. On the outside, we connect the monitor to the video card using one of three basic interface technologies. First, we have the Video Graphics Array, or VGA form factor. VGA has been around for a long time in personal computing. Here's an example of a female VGA port on the back of a computer's case. Now we're going to talk a little bit about serial port connections shortly. Serial ports look almost identical in terms of having that D shape, that form factor. However, the pinout, as it's called, is much different actually between a serial port and a VGA video port. Traditionally, you can spot a VGA port on a computer because the industry seems to have standardized on this blue color, and you'll also see 3 rows of 5 holes. VGA is really considered kind of an archaic or legacy video interface. It carries only a video signal, so you'd need to have a separate audio interface to support audio with your video. VGA not only refers to this form factor or this connector type, but also refers to standard monitor resolution. That is to say 640 by 480 pixels, 256 colors. So if somebody says, well, I've got a really bad video connection, or I'm just seeing VGA video, maybe we booted into safe mode to troubleshoot a Windows computer, you can understand that to mean that the video card may be far beyond VGA. It might be DVI or HDMI, but instead they're referring to a base, a very baseline screen resolution and color depth. More common today in the 21st century is the digital video interface, or DVI. Now, whereas VGA is an analog technology that uses the old waveforms, digital transmission are just ones and zeros, pure binary, pulses of electricity to denote either binary 0 or binary 1. DVI, again, carries video only, but it tends to be a much cleaner signal than VGA. You get less noise by virtue of its digital nature. Most contemporary computers and monitors nowadays, at least desktop ones, are going to use the DVI, of which you see an example of a monitor cable right here, as its default connectivity method. Now, you'll recall earlier in the training I mentioned that there's always a connector available. That is to say, you may have a DVI output on your video card on your computer, but your monitor may be a few years old and it has a VGA plug. How do you handle that? You can actually get converters that snap on the end of the cable that go from the DVI to the VGA and vice versa. I actually have an old PC in our great room in our home that's hooked up that way. The third type of video interface, this is the high-end interface, the high-definition multimedia interface. Now you'll notice, I hope, the trend in technology, that as technology marches on, you get more and more performance, and you get a smaller and smaller form factor, although that's not exactly true in this case because the VGA plug is smaller than the DVI one. But the HDMI is the best interface of all, and look at how tiny it is. It looks somewhat redolent of a USB or a FireWire plug. HDMI you'll find in mid to high range home entertainment systems, and more recently with computer setups. HDMI supports the transmission of both video and audio in digital format. Therefore, HDMI provides a cleaner connection in many cases because we simply have fewer cables to worry about. The digital signal, as I said, is used with both personal computers as well as televisions. You'll often find in contemporary camcorders and game consoles, the best way to connect those up is also to use the HDMI connector. Picture time. To review, we'll remember that video cards use some predefined interface technology to the motherboard. Back in the dark ages, we used what was called the ISA slot, very slow, very clunky interface. Then we wound up with the accelerated graphics port, or AGP, PCI, and now the most recent is PCI Express, or PCIe. In fact, let's do a search for PCIe slot and show you what those look like. So these are going to be the interface slots on the motherboard. This is a really nice graphic. I've used this before, where it shows the different standards. I hope another theme that you've picked up on in this training, as I've taken you gradually deeper and deeper into information technology, is not only as technology marches on, you wind up with form factors getting smaller, performance getting bigger, etc., but there's also standards within standards. What you're seeing here is in the PCI Express slot type, we have different standards there. Some run faster than others, as you see here. There's by 1, by 4, by 8, and by 16. Then we see some adapter plugs, as I told you, DVI to VGA, VGA to DVI. And this is showing a back of a computer case with a DVI monitor port. You'll find that to provide backward compatibility, sometimes you'll have PCIe or PCIe video cards that support multiple outputs. This particular one has 3. It gives us the high-end DVI connector. In the middle you have what's called S-Video. That again is a legacy video connectivity method. And then we have the VGA. Gradually though, as I said, you'll find the analog port, the VGA one, being deprecated, but it'll probably still take a few years for that to happen. Let's now review some peripheral device interfaces. First, remember the PS2. This is a legacy or old school connector that's used almost exclusively for the keyboard and mouse connections. As I've told you earlier, the industry tends to color code these so you know that blue is keyboard and I guess this is green is mouse, and also you'll find them labeled. The reason for this hopefully is clear. If these two PS2 ports were identical in color, how would you know which one corresponds to the keyboard bus and which one corresponds to the mouse bus? I mentioned that PS2 is problematic because it's not hot pluggable, which is directly in contrast to USB, and also PS2 has the pins, and whenever you have a connector with pins, you have the possibility of bending those pins if you're too aggressive in plugging in or unplugging a device. Let's talk in greater detail about universal serial bus. It really is truly a universal technology. You'll recall the difference between serial and parallel communications is serial is one bit following the other, whereas parallel is kind of like we have groups of bits being transmitted simultaneously. USB has different versions. The original specification of USB was 1.1, and you want to avoid those buses wherever possible. You can find USB 1.1 buses on older computers, like several years old. Actually, when you're looking at the back of a PC case and you're seeing the USB connectors, it's almost impossible, if not impossible, just by looking at them, to determine whether they're USB 1.1 or the current standard USB 2. As I said, if you're dealing with a computer that's a little bit sketchy in terms of age, you want to go into the host operating system. And for instance, in Microsoft Windows, there's the Device Manager utility where you can figure out sometimes manufacturers would have a bank of 1.1 ports and 2 ports. The reason why this is important is the vast speed difference between USB 1 and USB 2. Whereas USB 1.1 travels at 12 megabits per second, which seems like a lot, it pales in comparison to the 480 megabits per second that USB 2 supports. Of course, any contemporary computer or device that's been published in the last handful of years, as of this recording in late 2010 is going to be USB 2. There is a USB 3 in the works. Again, a theme in technology. We always have progress, but 2 is the current standard. Something else to consider is form factor with these. The two main interface types with a USB port or USB cable are the A and the B. You also have the mini B, but these are the main ones here. You see that the A connector is just your traditional rectangular interface. There are no pins. There's just a plastic disc in here that has copper connectivity wires on it. That is what you find in most connections. Sometimes you'll find an AB cable like you see here. The B is this fat connector that looks kind of like a capital B if you look at its shape. Now, when do we use that? Traditionally, when you have heavy-hitting external devices like optical drives, tape drives, and so on, you have the A jack that goes into the computer, into one of the USB 2 ports, and the B that goes into the external device. And as I said, there's a small form factor called Mini B that looks like this. Note that I didn't say Mini Me, I said Mini B. You'll find those on smaller removable drives. They'll oftentimes make use of this small form factor. But you can rest assured, as long as we're dealing with USB 2 technology, you're running at 480 megabits per second. A technology that I'm sure the inventors hoped would be as popular as USB, but unfortunately is not, is the IEEE standard number 1394. It's also called FireWire. Apple was a huge proponent of FireWire technology. They've had FireWire ports on many of their computers for several years. Neat thing about FireWire, there's actually quite a few things that are neat about it, is number one, its speed is very good. The original FireWire, what's called FireWire 400, that's what these interfaces are over here, is comparable but slower than USB 2. However, the faster spec, FireWire 800, which you see over here, is 800 megabits per second. That's a little less than double the speed of USB 2. So, especially Mac people and folks who are into video, heavy-duty video editing, and other high-bandwidth data transfer tend to use FireWire interfaces, in particular the FireWire 800. Another neat thing, yet again, about FireWire is that FireWire can actually transmit network data. That is, Internet Protocol or IP addresses can be assigned to a FireWire interface, and you can actually transmit data that way in addition to using your traditional file sharing or FireWire protocols. Like any other technology, there's variant form factors for IEEE 1394A, which is the 400 Mbps, and the 1394B, that's the 800 Mbps. There's the traditional D-shaped connector, and there's also a mini form factor there in order to save some space when you're connecting, say, a smaller form factor hard drive. As an IT sales representative, it's important for you to understand the historicity, if you don't mind the $5 word, of these connector types, these interface types. Even though the serial and the parallel buses and serial and parallel connectors have gone the way of the dodo in current computers, at least in most part, as I said, you're going to have a lot more credibility with your clients and customers if you can speak intelligently of the evolution of technology over the years. So to that end, let's take a look at first serial connectors. Remember the VGA connector that we showed you earlier, that 15-pin connector, 3 rows of 5. Serial means that data is transmitted bit after bit. The form factor uses the D shell, but you'll note that the interface connector, these are actually MAL pins. It's a MAL connector that goes to the motherboard. And then your serial plug that's connected to your mouse or tape drive or whatever you're doing serially fastens over the serial connector on the back of the PC. And you'll note because the plug tends to be kind of large, you have what are called fastening screws or thumb screws that you can lock the plug into the interface. So serial was originally a standard peripheral interface in personal computers used for external modems, mice. Believe it or not, in IT you'll still find this serial interface, formerly called RS-232, that's the form factor here, for doing network administration tasks. For instance, by linking up a workstation PC to router hardware, switch hardware, firewall hardware in order to perform initial configuration of those devices. So in essence, serial is still around for very specialized purposes, but as a standard issue peripheral interface, it's gone. Parallel is originally or was originally designed for peripherals like printers, scanners. If you remember the company iOmega, back in the late 90s, they created a removable media tape cartridge called the Zip cartridge and the zip drive. Those little guys, they were about twice as big as a 3.5-inch floppy disk, and each one stored 100 megabytes. And at that time, that was a really big deal. These iOmega devices came in two interfaces. They would use either the parallel interface or they'd use the more expensive server-intended SCSI interface that we talked about earlier in the training. Parallel ports are not hot pluggable, neither are serial. They're a bear to configure, they're slow, and they tend to be unreliable. So do we still have them nowadays? I sure hope not. Parallel ports are often called printer ports, and you see this is showing the back of a PC case with an exposed parallel interface. You see an icon of a printed page to let the individual know what kind of port we're dealing with here. Typically, when you're connecting a parallel device, like a printer or a scanner, you have a double-headed cable where one side of the cable is your MAL parallel port interface, and then the other interface that connects to the hardware uses a different form factor. It always reminds me of a shark opening its mouth. This is called the Centronics interface, and it's a pretty thick interface as you can see from these pictures, and the way it works is you plug this into the back of your printer scanner, and then the printer scanner has these metal loops that come over the Centronics ends here and locks this guy in place. On the PC side, as I've already said, we have these thumb screws to secure the plug to the motherboard. Finally, let's re-examine network interfaces. You'll recall that our three basic network technologies are Bluetooth, 802.11 wireless, and 802.3 wired Ethernet. With Bluetooth, this technology or this interface can be embedded within the computer itself or via USB dongle. Now, what is a dongle? A dongle is a little plug that, interestingly enough, tends to use USB 2 that gives Bluetooth wireless capability to the host device. I think I gave you the earlier example showing you this picture, that on my main laptop computer I have a Bluetooth wireless mouse that connects via this USB dongle that's so small. You can see in this picture the dongle is a little larger than this person's thumbnail that provides that Bluetooth interface. 802.11 wireless, the wireless interface cards, if they're internal, are going to use some variant of the PCI bus. External wireless cards can be put in laptops using what's called the PC card standard. They could use the Express card standard. We're going to learn about that a little bit later, so hang on to your hats. And there are even USB wireless adapters. You can consider them to be sort of like thumb drives. Here's one right here made by Linksys. Looks like a thumb drive. You plug it into a USB 2.0 port on your computer, load the driver, and suddenly you have wireless connectivity. Isn't that great? You might be asking yourself, well, where's the antenna? Some of these devices, as you see here, do have an external antenna. In my experience, these USB 802.11 wireless interfaces that do have an antenna are going to give you better range and performance than the ones that go for the low profile that always do have an antenna. It's just in this case the antenna is embedded within the case. Finally, with traditional wired Ethernet, the main standard there is the RJ45 unshielded twisted pair cable that comes in various categories or grades. The two main grades for Ethernet nowadays are either category 5E or 6. They are interchangeable, they look identical. The only way you can tell the difference between a category 5 and a category 6 cable is by reading the jacket of the cable where you'll find that printed. What we haven't talked about, because it's not indicated in the exam objectives, but I think is important to show you, is fiber optic cable. Fiber optic cable is capable of not only much higher data transmission speeds than traditional copper cable like the unshielded twisted pair that we've been talking about thus far, but also fiber optic cable can go for much longer distances. Instead of 100 meters like copper cable, you can go up to 2 kilometers with a single run of fiber optics. Therefore, in the IT industry, you tend to find fiber optic cable used for cable runs between buildings on a campus, potentially even longer runs yet. I mean, 2 kilometers is quite a distance. Fiber optic cables, because they shoot beams of light through these little glass fibers, are by their very nature fragile cables. Because the cables are fragile, you want to treat them very gingerly. You'll see here that fiber optic cables have a number of different connector types. You'll notice that pretty much the only thing they share in common, and even at that, not all of them seem to, is this little clear cap here that covers the glass tubes, or shall we say fibers, through which the optic or the light beam goes through. Because of their speed, because of fiber optics' high technology, because of their long cable run length, fiber optic cables tend to be very expensive. Here's a nice picture that shows you the outer jacket of the cable, the cladding or shielding, and then the actual fiber wire inside. But as I said in my original point, these are still pretty expensive, so the days of having a fully fiber optic local area network are not yet with us. Traditionally, we're going to have copper wire connecting the computers to the workgroup switches, and then we'll just have fiber optics running to connect our switches and routers and basically collapse the core of the local area network. And then finally, to connect buildings and a campus, fiber optic is perfectly suited for that. Setting up a PC part 1 of 2 review. In this nugget, we did in fact review the common interfaces for peripheral devices and core devices in personal computer systems, and then we completed by examining, or should I say re-examining, our common network connectors and cable types. I hope that this has been informative for you, and I'd like to thank you for viewing.